There we are. No, and I just have to find the real starting point. Okay, so how to proceed? I mean, these are more general comments. This is not involved with the comments on what spectral function to use and what not. And I try to be somewhat provocative also, so in order to get you all woken up again. So I think, first of all, you all agree the generator is an important part of any experiment. I mean, this was just something Christopher pointed out again. In particular, if you are setting up a $1 billion experiment, and if, in particular, if you are setting up a $1 billion experiment like L, B, and E, you do not want to have at the end of your line a guy with a crummy code that on whose performance you rely. And you have to realize, I mean, even if your experimental equipment is top of the class, so to say, I mean, what comes out at the end decides some guy with a generator, okay? So that shows how important generator people are, Steve. And then the first conclusion from that, taking these 1 billion, it's clear, generator sort of theory support must be an integral part of any experiment and its funding. And I mean, I like this guy Harris. Here is Harris again, before I come to the real thing. Harris sits here stable, and there two guys look here and say, what we especially like about the theoretical types is they don't tie up thousands of dollars worth of equipment. Now I've replaced that thousands of dollars by millions, but that's more modern. This was drawn up in the 70s. So, I mean, this is something, in a $1 billion project, there ought to be money for dedicated support for generator work. I think it's not appropriate if a guy like Steve with one student or so sits alone there and cranks the code and you is somewhere there, and that's it. That's just not, I mean, these guys can't do everything. Now, let's go, okay. I think precision era physics now requires better generators. And I make a few statements on that. First of all, 2009 at INT, we had a very, very useful comparison of generator predictions that was mainly produced by these two guys here. And I think the community still should be thankful to them. They showed generator comparisons for pions, for QE and so on, and you saw curves all over the place. But I think by now, 4 years later, we do not need further generator comparisons. We need to understand why these generators were so different. That is hard to do because it has something to do with this fact that many of these generators are black boxes. The documentation is sort of missing. You do not find out about the physics input, but you also do not find out simply about practical implementations, like numerical implementations. And I think, I mean, whenever you guys build a detector nowadays, you have to go through all sorts of reviews. There are technical design reports to show, and you have to prove that your electronics will do the right time resolution and energy resolution, what have you. Such a thing, I think, in such a big project like LBE would be necessary as well. There should be a TDR for generators, so to say, where really a sort of review committee goes through that and sees, is this really state of the art? Is that the best thing we can do for the moment? That should be part of the approval process of this whole thing. And that essentially, if you make that part of the approval process of a big experiment, that would underline at the same time the importance of the generator work and would feed back on their support, so to say. Yeah.
So just to also further refine and clarify this point, I think going back to what the point that Jorge and Chris were making, it also matters which differences you focus on and where you start. I mean, I can sit down from T to K and tell you where I think the big problems are going to be. People on Minerva probably can tell you where the big problems are going to be.
Yeah.
Make those comparisons, pick your biggest things that you think you're going to have to fight with in the analysis first, and dig into and really refine those models first. Then go into the weeds and get into some of the details.
Yeah, but
it really matters which comparisons you
But I'm more general with my comments now. I mean, at NUIN, the comparison was mainly on QE and pions. These are clearly the two most dominant things, and one has to understand why things go wrong there, or why things go different, let's say, in these generators, and so far that's not possible. I require and insist on write-ups for generators which contain not only the physics input that goes in there in terms of crossover or something like that, but as also the inner workings. Genie is the first generator that has put out such a work of 90 pages or something like that, I still find it unsatisfactory. It makes nice reading, it has all the right words, but it has very few real essential technical details on it, and that would have to be supplemented in there. Now I go on. Precision error requires better generators. So what we have then is, I mean, the present generators, I think, and this was my impression now from this first week, have evolved into a patchwork of theories, recipes, and fit parameters, often without theoretical justification. I mean, I went up last week already on this consistency argument between two particles, one hole, and so on. I had this another example of background under resonances, where some background is taken from some theory, calculated for something quite properly, but then rescaled to fit for something else. So that's what I would call as a patchwork. There are patchworks of here and there, and there's a Fermi gas here, and there's a Nieves model there, and this is all somehow brought together into one program, and at the end comes a line. So that has come out, and I think the danger one has in doing that is clear. One loses any predictive power. I mean, you don't know what you are doing at the end. You may be able to fit enough parameters to your data and describe data at one given experiment, but not more. So then the question is what to do. I think it's time to critically really scrutinize existing generator. Again, meaning that you have access to the info, what's in there. Take the best parts from any of them. You know, I mean, maybe Genie has that part perfectly well, Newt has that part perfectly well. Supplement that with a consistent theory and then build a new generator. And I think it's time to do that. I've called it New Genie. So, I mean, that's a double meaning of the word, of course, here. So I think it's time really to start a new generator, where one really is not burdened with all this history that was there. The generator started once for completely different experiments and then evolved somehow. By now one can throw this stuff away. Suppose you have enough support, which is always mandatory, and I think which would be there in a billion-dollar experiment. That's quite clear, and every funding agency should buy that. So the guiding principles for any new generators from a theory point of view, first of all, consistency. I insisted on that last week, just that little example, consistency. I mean, at least the ground state should be the same for all various sub-processes one has in generators. There shouldn't be a uniform Fermi gas for one process and another one has a bound state local gas and things like that. Second is detailed balance, one of the typical things.
Sorry, can I ask a question on that? In your specific example?
Yeah.
I mean, I feel like I had this conversation with Nieves at the last NUINT where we said, okay, so we see spectral function is important or something is needed more for QE. Could we do that for 1 pi? And the answer was, like, do you have a suggestion for how, if you say on one hand we want the latest and greatest,
we can
and
talk,
you hate Fermi gas, I can't do all of the best things for all the models all the time.
well,
So
but I think you can develop with the consistent framework. Consistency is more important for me than, I mean, having the best model for pions, but then maybe have a lousy model for QE or the other way around. So you have to be consistent. Second is detailed.
You're saying, so right now I'm saying, those are not compatible statements. Right now I would have to take the crappy, Fermi gas model for everything if I want to be consistent. And I don't want to tie myself to that when we've seen great evidence for great new models right now that I would much rather use.
Let me go on. Detailed balance. Second principle, I think no theorist will argue about detailed balance. You want to have detailed balance, that means a process can go in 2 ways with the same matrix element, okay? That's basic quantum mechanics. For example, for pion absorption, I just took that example here, you have a pi-less decay, delta plus n goes to nn. That's one of the dominant pion channels, the absorption channels. It's not the only one, there's also a 3-body absorption, mind you, but this one here. But then once you have that channel, you also want to have that channel, and n goes to delta n. I learned last week that somehow, I think it was Newt just takes 20% out and just throws them away of all the deltas, and that somehow accounts for delta plus n here.
They're kept in the analysis.
Hold it. This is all, but this is, okay, I insist on this thing here. I mean, you have to have detailed balance. You have to be able to recreate deltas in the final state. If you don't, then you are violating basic physical principles. Third thing is relativity. I haven't been able, even though I have talked to many people, to find out how collisions are actually handled. I get a vague idea. Just want to point out suppose you wanted to build a sort of generator by colliding billiard balls. The most naive thing that comes to your mind, you know, you have to decide when things do scatter, where you have a cross section, you say sigma is equal to pi